Welcome back to the Python Made Easy series, Python community. We are going to be talking about working with CSV files today. We will read from them. We're going to write to them. We'll even have one piece of code that does both in one fell swoop. We will look at how we analyze data using them. No more Excel VBA. We can do it all in Python. No need to manipulate it in an Excel file. I think we're going to have a lot of fun with this. Maybe in your job you have called to work with CSV files or Excel files that you can convert into CSV files to manipulate data where I work. So how can I work with CSV files using Python? Python comes with a CSV module. This can be used to work with data exported from spreadsheets like Excel and also data from databases. This data is first exported into a CSV or comma-separated value format. This is just a text format with fields and records that are typically separated by commas. We're going to get into it. So here we start out gently by reading from a CSV file. So this is a CSV file we're reading from in this exercise. We first import the CSV module into our code, which is the Python module used for reading and writing to CSV files. We use the with context manager here with the open function, which opens a file for use. Its first argument is the file name in quotes. We use new line set to close quotes because if it's not set, new lines embedded inside quote fields may not be interpreted correctly. And on platforms that use the return carriage and new line endings on write, an extra return carriage may be added if we don't use it. The reader function returns a reader object which will iterate over the lines of the CSV file. Each row read from the file is returned as a list of strings. So you see what the output is here when we go through our iterator for row in reader print row. Now I made one change here on this second version for the benefit of the viewers of this class. Here you see that as my second argument in our open function, I included an encoding equals UTF-8sig. So UTF-8sig removes BOM if present, and BOM stands for byte order mark. This relates to the 16-bit Unicode transformation format. And Unicode is just an industry standard for the consistent encoding and representation and handling of text and writing systems. So when I do this, you see my code down here no longer has these funky characters before my first string name. Okay, now we'll look at writing to a CSV file. On the left-hand side is the code. On the right-hand side of this slide is the CSV file that we create through this code. So we import CSV as always. We create a list of lists as the data we will write to our CSV. So we're going to take this object rows and we're going to write it to our CSV. This is our list of field names or column headers, this headers variable. This our file variable, this is the variable that represents the CSV file we want to create. Here we use a context manager to open our file for writing. This time we use the W attribute, and we store it in a variable f. We let f represent that file for writing. Now here, writer equals the writer function. This returns a writer object responsible for converting the user data into delimited strings on the given file-like object. And here, we use the write row function to write the rows parameters to the writer's file object. And finally here, we use the write rows function to write the rows, an iterable of row objects to the writer's file object. So when we execute this code, we see that it automatically creates this file if it hasn't been created, and in our case it wasn't. We write out the headers and we write out the data from our rows list. Okay, here we're going to read from one file and write to another based on conditions. On the left-hand side, as always, we have our code. On the right-hand side is our CSV output file. So we start as we always do. We import CSV. We're going to import the date module from date time because we're going to use that in one of our functions here. You see at the top I have now equals date dot today. So I'm going to use this in this very first function called get file. This function creates the file name to use automatically. And for me, it's going to be a concatenation of gaps underscore plus today's date and of course the extension .csv. So this way I can assign this function, the output of this function, to a variable called name like I do right here and use it in my next function to actually create the file and write to it. So here in the second function, create file, I'm going to do just that. So here we feed the open function, the output of our get file function, which is concatenation again of the strings gap underscore today's date and CSV. Right here, field names are what we are labeling our column headers in order of appearance, in the order you see it here in the list. Writer, we use the dict writer function here. This operates like a regular writer, but it maps dictionaries onto output rows. This needs the field name parameters to specify the row headers. That's one requirement of this function. Here, this writes a row with the field names from the dict writer object. Okay, now we have our context manager with open. We pass it the directory that this file lives in, my data / and then the name of the file we're going to read, which is daily underscore file underscore 2019 0130.csv. We have R for read, and we're calling this daily, right? So the variable daily is what will represent that. So then we have rows equals csv.reader daily. And of course, daily represents our file. So that's our reader object. And then line equals 1. You see here, I use line as just a counter because I want to be able to count how many gaps I have. This whole thing is to read one file. It has a certain amount of gaps, and I want to read that into a new file. So I'm going to create a unique identifier for those gaps that's meaningful to me. And in my particular case, it's going to be the date plus a unique identifier, like a number 1, number 2, number 3. And it'll just increment as we go through our for loop here. And you see, I do that courtesy of this line right here. You see new line equals a casted string on now, and with my line, which starts at 1, and then here it increments. So that's all I'm doing there for that very first column. And you see it works like a charm in the output. For rows and rows, if row 5 equals high. So this is where my conditional comes in. Row 5, of course, is going to be the 4th column, because we use zero-based indexing with Python. And this will write the rows that meet my condition statement. If row 5, which is really column 4, is high, write those rows only. I don't care about anything else. That's how I get the conditional output from this original CSV file. Then, of course, I increment my line plus equals 1. So each time I go through this data, this file that it's reading, this CSV file it's reading, it's going to increment that, and I'm going to get my unique identifier that you see here in column A. Then to print, I just use a separator here of stars times 50, and I return the name variable plus has been successfully created on date and today's date. And finally, I print create file, which is this function where all this code is, and I pass it name, which is the name of my file. And bing, bang, boom, we have the output here. So a lot going on. Take it slow, take a look at this. But this is a great example of how to read from one file and write to another all in one piece of code using CSV on both ends. In this piece of code, we'll read data from our file to get an average. So now we're actually going to get into the guts of the data in the CSV. So on the left-hand side, this is a subsection only. This code is in the same file as our previous code. And again, I'll have this up on GitHub so you'll be able to see the whole thing. But I'll just highlight the sections that are pertinent to what we're trying to do here. Of course, on the right-hand side is the output file, which is now our input file for this exercise. This is what we're going to read to extract this data and manipulate it. So I have a get average function. It takes field name as its only argument. So the context manager with open name, we're going to read it as output. And again, name is from the previous slide. Rows equals csv.dictReader, and we pass it output, which is the variable for our file being read. So dictReader, I don't think we've seen this before, creates an object that operates like a regular reader, but it maps the information in each row to an ordered dict or an ordered dictionary whose keys are given by the optional field names parameter. Now, I have a whole dictionaries class where we go into ordered dicts, and if you're confused on what that is, you probably want to take a look there. Then I have a variable x, which is equal to 0, and count, which is equal to 0. So I do 4 row in rows. And then I have this very strange looking statement, x equals x plus int row dot dunder get item and field name, which is what I'm passing in down below. And in this case, that's the header, right? I want to be able to select the column. So it's percent complete is what I'm selecting here. So since the dict reader function returns an ordered dict from the Python collections module, I'm able to use any of its methods. And one of its dunders is get item. This method allows me to get the value of each item in a given column. And in this case, I'm choosing, again, the percent complete column, as you can see here in column G on the right-hand side. I convert each item to an int, and I add it to my variable x. I do this in order to get a total. Then I use a second variable count to see how many times I loop around, and I get 12 in this particular case, 12 rows of data. From there, it's easy division to get the average of all the percentage completes for each row. And you see I do that right here. X, I convert this to a string as well, but X divided by count. So you see the output is the percent complete on high rated items is 29.75%. So what I do here is I just add all of these up. I divide by the total number of rows, which is 12, and I get my 29.75%. So pretty slick, pretty easy to do this. And if you wanted to, say you had a large set of data and you wanted to do this on various different columns, all you would have to do when you run this is for this print get average, instead of percent complete, you can put whatever it is. If there was, data in LOB, in the LOB column here, or the ID column, or the category column, you would be able to do that with just one simple change in your code. But a lot of fun. And in this snippet of code, we're going to read from our file, our same file, to get unique item counts for a particular column. So again, code on the left-hand side, the same file that we're reading from on the right-hand side. We have a function called get_unique. It takes, again, field name, which we'll use down at the bottom, where we say get unique, and we're going to use category this time. The category column, which is the fourth column over here in our data set. So context manager with open name for reading as output, same as always, because we're using the same file. Rows equals csv.dict reader output. We explained the dict reader on the previous slide, so that is the same. Here, for number one, this is an empty list, list_names. We'll use this to build our unique data counts for the elements. And two, again, is going to be our counter. This is our counter. It's an integer that will increment each time another unique value is added to our list of unique items, list_names. We have a for loop for row in rows. This first branch of the if statement instructs if the item is already in our list, just continue, take no action. And if it's not, in the else branch, having already asked to move on, if the item is already in our list in the if branch, the only other option is it's not in our list. So if it's not in our list, we will add it to our list_names list. Then we increment our counter. And finally, we have a print statement that says there are blank for our string formatting, unique values in this field. We use the count number. And you see that for category, we use category here. It's the same idea. We put in category and we say, oh, there are 3 unique values in this field. And then we say, column. And then here we change it to LOB. And there are 8 unique values in this field. And you can look at the data snippet of the 12 lines of data. You can see that it did exactly what it's supposed to do. So pretty neat and very easy to get unique counts from a column reading a CSV file with Python. And as I always try to do with these classes, my people, I have saved the best for last. Here, we're going to read data from a file to get a count of each unique item and the percentage it holds against the total of our population. Woo! As always, code on the left-hand side. The file we're reading from on the right-hand side, it's the same as always, so these first few lines are very similar. We have a function that we now call group_me. So we're going to group these together to count them. We have field num as its one parameter that it takes. And in this case, we have our with open, we read our file, we pass it in there as output, same as always, but we pass in the file instead of using the name variable as we have been. And then we have rows, and this time we're using the csv.reader. So instead of using dict reader, I'm using reader, the reader function, as it works better with this particular snippet of code, it makes things more straightforward for the code that's coming next. So this next line here, next rows, comma, none, that's just to skip the header, right? Because I don't want my header in the population here where I'm counting these up. 4 rows and rows. Now, ref underscore orig dot pen, and I feed it rows. What am I doing there? I use this list as a counter so that I have the total population to use later when I want to determine the percentage of each line against the total population. You'll see why I do that. 4 here, number 4, if item is not already in my dictionary, ref underscore count, which I defined outside of my function as an empty dict, add it, and it'll add it with a value of 0. Number 5 here, with each iteration for each item presented, add to the value by incrementing by 1. You see what I do here? Then for 6 here, this is our caller, and we pass it the index 2. So no more header names in quotes. Now we're just going to pass it the index of 2, which is column 3, right? Because Python, of course, uses zero-based indexing. So now we'll unpack the values or the item names, and then the keys, the item count, from our dictionary ref underscore count. Then we get the percentage of each item against the whole by using our ref underscore orig. Now you see why I did that, which we built above. This gave us the total population of our column as we iterated over each. So the only thing I do here in this printed out string formatting is K and V, K for keys, V for value. I round it, V, the values, divided by the length of that ref underscore orig times 100. My rounding is to one place, and you see the output with some cutesy little print statements that I have here. I have item IT with a count of 3. It represents 25% of the population. I have item ACCT, which represents the accounting department. Count of 1, 8.3%. Facilities, count of 2, 16.7%. And then at the bottom, I print out the total population. And then I give that, of course, len. I can use the same statement, the length of my ref underscore orig list. So that's it. Pretty simple, not that much code to, again, get through this CSV file and do some pretty useful stuff. Okay, Python family, thank you for watching till the end. If this class has helped you, consider helping me to continue to bring these classes to you and others. Helping is easy. Just do the following. First, subscribe to the Yogi Coder YouTube channel. Next, like this video and leave whatever comments and or questions you like. And finally, share this video on any and all social media channels with your friends and colleagues. And as always, this presentation and its associated code will be stored up on GitHub at the link in the section below. Thanks so much, folks, and I'll see you in the next one.